Alright, calculus. So I thought I had done this video, but for some reason it wasn't registering when I tried to play it, which is weird because it did work, but now we're doing it again. So that just makes us better because we're doing it multiple times. So let's go ahead and get started. We're looking at part 2 here just to review the things that we're going to be seeing are implicit differentiation, continuity differential related rates, and a tiny bit of function analysis that's coming into the second half of this video, but I'm going to focus mostly on the first three. So the first thing, implicit differentiation. How do I know this is implicit differentiation? Well, first thing, I see mixes of x, y, and x squared in here. Then what that would mean is that we are going to be taking the derivative, but every time you take the derivative of something with a y in it, that's going to be dy dx added onto it. Or if it's the derivative with respect to x of a function of y, that's going to be f prime of y, the derivative like we normally would, but then dy dx. We always have this residual piece, the chain kind of left over on that. So let's just take it one step at a time. Let's start with the first term. X squared, take the derivative, is 2x. The next one we have xy, which is actually going to be a product rule. The derivative of the second one times first, and the first one times the second. That's one way we can look at that. So it's going to be x times the derivative of the second, which is dy dx. And the second is going to be y times the derivative of the first, which is just 1. The derivative of x is just 1. Then we have minus y. Well, y, the derivative of y with respect to x, is just dy dx, or 1 dy dx. And then we have equals 0, because the derivative of 7 is 0. All right, let's kind of separate and regroup this a little bit. First thing, I have 2x, and I got a plus y, plus x dy dx, minus 1 times dy dx, equals 0. I'm going to move this 2x plus y over to the other side. That's going to give me negative 2x, negative y. Then on the left side, I could factor out this dy dx. We'll have x minus 1. If I divide both sides by that factor there, x minus 1, that gives me dy dx. I have dy dx equals this big complex fraction here. So it's saying find dy dx, not just find dy dx, but a specific x and y value. So we got to plug in x equals 3 and y equals negative 1. So then that's going to lead me to get negative 2 times 3 for x, and minus y, which is negative 1. Then on the bottom we have x minus 1, which is going to be 3 minus 1. Now, if I simplify this even more, that would be negative 6 plus 1 over 2, it looks like. Is that right? Yeah, it is. So that's going to give me negative 5 over 2. And that's one of my options, C. Looks like for the other options, people are just kind of simply doing the math a little incorrectly, or they're not remembering this dy dx, and then they're just plugging things in. So you got to be careful with those minor details because they do matter in the long run. Next one here. At which points is the tangent line to the curve vertical? Okay, so vertical, let's talk about this. We got vertical tangent lines, and we got horizontal. Now, if we think about slope, we often think of rise and run kind of as our options. And those also relate to the ideas of vertical and horizontal. So if slope is rise over run, and we're vertical, that means we're rising, but run is not there. Run is just 0. So I'm going to find dy dx equals some fraction. Then I'm going to take this bottom piece and set it equal to 0. Okay, let's do that. So we do this one term at a time. The first term is 8x squared. The derivative of that is going to be 16x. The second term says 2y squared. That's going to become plus 4y. Then we have this dy dx to go with it. The next term, now this is just a little bit of strategy on my part. I'm going to group this as 6x for the first half and y for the second. In other words, a equals 6x and b equals y. And we're looking for a b prime plus b a prime. So a b prime, that's going to be 6x times b prime, or dy dx. And b a prime, the product rule here that we got, y times the derivative of the first one is 6. Okay, so now let's start regrouping. I see that I have this dy dx term here, and I got a 6x dy dx over here, so I'm going to move the 6x over to the left. And then the non-dy dx's, the 16x and the y to the 6, I'm going to move the 16x over to the other side. So that would give me 6y minus 16x is equal to, on the other side, dy dx times, let's see, what do we got? 4y minus 6x. Alright, so now if we divide by that 4y minus 6x on both sides, 4y, not 4x, 4y minus 6x, that gives me dy dx. And remember, we're talking about just the denominator, because for us to have a vertical line, denominator equals 0. So that means that 4y minus 6x equals 0. Now that I'm here, I can actually answer the question fully. We have all these options here. We got 2 or 3, 1, 2, or 3. So for the first one, I'm going to plug in these two numbers, x and y, and see what comes out. So the y is negative 3, so that's 4 times negative 3. The x is negative 2, so that's minus 6 times negative 2. That's going to be equal to 0. That would give us negative 12 plus 12. That's definitely equal to 0. So first one, true. Let's check the next one. 3 and 8. Remember, again, this is our x and our y. So that's going to become 4 times 8 minus 6 times 3, or 32 minus 18. That does not equal 0. So that's false. Let's move into another one here. Give me a new color. How about brown? Sure. So for brown, we're looking at this 4 and 6. That's going to be 4 times 6 minus 6 times 4. Actually, you should kind of have some intuition here. It's 24, 24. That does equal 0. Check. So this is also true. So 1 and 3 only, not 2. And even just by disproving 2, I could have canceled out B and D and at least increased my answers there. And even C, because I knew 1 at that point. So just by doing part of the problem, sometimes you can at least give yourself a 50% chance or better. Consider that. Let's look at number 14. We're going to do just a few more here. Continuity and differentiable. Describe the behavior. Okay, so we got limits, we got continuous, we got differentiable. Okay, so when we're talking about limits, that of f of x exists. That's really just meaning that the left side equals the right side. When we're talking about continuous, that means the left equals the right, but it also means that the middle is included in that. Remember, when we're talking about left is kind of like less than 0. Well, it is. Right is greater than 0, or greater than a. I guess it doesn't mean 0. And left is less than that value. Right is greater than that value, but middle is when it's equal to that value. Now, differentiable is interesting because if it's differentiable, that means that f prime of x is continuous. Okay, so let's check these things. Let's check number one. What's the limit as x approaches 3, let's say from the right? Well, if we're talking about from the right, that means we're going to do the top function. That's going to be x squared minus 5x plus 8. So if we're saying as x approaches 3, that's going to be 3 squared minus 5 times 3 plus 8, which is 9 minus 15 plus 8. 9 minus 7, that's 2. The limit as x approaches 3 from the left means we use the other function, x minus 1. And that's pretty easy. That's just 3 minus 1. That also equals 2. So that's true. Number 1, check. That's true. Let's look at, so this was number 1. Let's look at number 2. Number 2 is also true. How can we jump to it that fast? Well, because when x is greater than or equal to 3, this or equal to, that includes the middle. So that means that f of 3 is equal to the limit as x approaches 3 from the right. So we've already checked those two things. Let's check the third thing then. So for the third stage here, we're asking differentiable. For us to be differentiable, we need to look at the limit as x approaches 3 from the left and the limit as x approaches 3 from the right, but this time of f prime of x. So the derivative then would be limit as x approaches 3 from the left of 1, because the derivative of x minus 1 is just 1. And for the other one, it's going to be the limit as x approaches 3 from the right of 2x minus 5. So we plug in 3, and that would give me 2 times 3 minus 5, which equals 1. So that's true too. The slopes are equal to each other as well. They're the same from the left, same from the right. They're nice and smooth. Then that means we are differentiable. So all three are true. Check, check, check. That'd be D. Let's move on to number 15 here. Related rates. Ooh, related rates. Well, let's work our way through this. Matthew is visiting Gregory at his home on North Street. Shortly after Matthew leaves, Gregory realizes that Matthew left his wallet, blah, 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 blah. Okay, so here's the numbers. Matthew is 3 miles north. So this right here, this is 3. It's kind of small in your picture. I'm just drawing a little bit bigger. Then the other piece, and we'll do this in color. So let's say that the vertical here is red. That's 3. And then the horizontal will be blue. That's 4. It says, at that time, how fast is the distance between the two men changing? Okay, so right here also, there's a difference in speed. Looks like this is 45 miles an hour toward the intersection. So right here, dg dt, or the rate of Greg with respect to time, is equal to negative 45. And you're probably wondering, why is it negative? He's moving forward. He is. But this distance of him to the intersection is negative 45. It's negative. It's decreasing. The second one looks like Matthew is increasing, so that's going to be dm dt. He's increasing, so it's going to be a positive, and that's increasing at a rate of 30 miles per hour at this moment in time that we're talking about. The question is not how fast they're moving individually, but how fast is this distance between them changing? So how do we call it? What do we even want to call this? How about this? We'll call it dz dt. Just because it's not g and it's not n. So the distance between them, dz dt. Well, we know that g squared plus m squared equals z squared. That should be purple. Z squared. Let's erase this. Rewrite that. Z squared. How do I know that? Because this is a Pythagorean theorem. It's a right triangle. And when you're talking about the legs of a right triangle and the hypotenuse of a right triangle and trying to relate those three things together, you're either going to use trig or Pythagorean theorem. Now, because we're talking about the three distances and we have nothing to say about the angles that we're really measuring, then we'll use Pythagorean theorem. Because this is related rates, I got to somehow relate the rates of the three pieces. So to find the rates, I got to take a derivative with respect to time. So this first one will become 2g dg dt. Similarly, the second one will become 2m dm dt. Because we're taking the derivative with respect to time. The last one's 2z dz dt. Now I just got to do some algebra. I could divide everything by 2 and get rid of these 2's. Just multiply both sides by a half, I guess you could say. That means I can start plugging in now. I know what g is. How far is Greg? He's 3 miles. That's the measurement we have. dg dt is negative 45. Matthew is 4 miles. He's moving at 30, but increasing, so it's positive 30. And z is, oh, we didn't figure that out. Well, this shouldn't be too hard. This is a 3 and a 4, and this is a right triangle. So if you know your Pythagorean triples, 3, 4, 5. Let's see. So that means that this is 5. Now we're left with trying to figure out dz dt, which this is the distance between. Okay. So what do we do here? I guess it's just some algebra. We got negative 135 plus 120 equals 5 dz dt. If we divide both sides by 5. Negative 135 plus 120 is really negative 15. So that's just negative 3. Or decreasing at a rate of 3. That would be A. Now I know I kind of raced through that, but the general idea is, one, you got to relate the pieces with an equation. Relate the pieces with an equation, which requires that you label everything. Second thing, we got to do the ddt. And then the third thing is substitute the pieces you know and solve for what you don't know or what they're asking you to find. Okay, let's look at the next one. I think this is the last one for this section. Just to double check. Yeah, that is the last one. It says a cylinder has both its height and radius changing. Okay. A height is increasing. All right, I'm going to stop there. It says height increasing 3. So that means that dh dt equals 3. Okay, and next it says the height of the cylinder is 8. Okay, so that tells me that h equals 8. The radius is 2, so r equals 2. The volume is not changing. That's an interesting statement. Let's see what they're asking us. How fast is the radius decreasing? Okay, so they're asking us dr dt, or the rate of change of the radius r, equals what? Well, we don't know. But looking at this, how does this volume not changing fit into that? Well, volume not changing. That means the rate of change of the volume is nothing, or 0. So that means dv dt equals 0. So we're going to use all of these together to solve for dr dt. We just need an equation. Dun, da, 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 that ties them all together, like v equals pi r squared h. Well, let's use that. Volume equals pi times the radius squared times the height. Well, if we take the derivative of this, the left side will be dv dt. We got pi. Now this is going to be a product rule, r squared and h. We have an a and a b. We're going to have a prime, or ab prime plus ba prime. So it's going to be r squared times dh dt plus h times 2r dr dt. Okay, let's plug in what we know and then start doing some algebra. We know that this is 0. We have pi. dv dt is 0, and then we have pi. R is 2, so it's going to be 2 squared. dh dt is 3. H is 8. 2r is going to be 2 times 2. And then we got the dr dt. Okay, let's simplify a little bit more. We'll still have pi times 2 squared is 4 times 3 is 12. 8 times 2 times 2 is 32. dr dt. That equals 0. Okay, solving this a little bit more, if I multiply both sides by 1 over pi, or divide by pi, 0 divided by anything is still 0. So we have 0 equals 12 plus 32 dr dt. Simplifying this a little bit, we'll have negative 12 equals 32 dr dt. Divide by 32. I know that, let's see, 6 goes into each. No, 6 doesn't go into each of those. 4 goes into each of those. 4 goes into 12 3 times. And into 32 8 times. Now, I know it might not be exactly obvious, but the answer is going to be B. Even though this says negative 3/8, that means decreasing, which they already said right here in the prompt. They said, how fast is it decreasing? Well, it's decreasing at a rate of 3/8 meters per minute. Okay, I think that's it. Just to double check, yeah, because we were looking at this video. Oh no, you know what? We didn't do this one. Well, you know what? Go ahead and ask a question about this one in class, but just the key thing about here, mean value theorem. Actually, I'll go ahead and go, because I'm going to connect it to the next video anyways. So mean value theorem. Mean value theorem means that the average rate equals the instant rate. And for the average to equal the instant, that means that the slope, or f of b minus f of a over b minus a, the old school slope equation, is going to equal our f prime, our derivative. So let's calculate that. F of b minus f of a over b minus a is really equal to 1 cubed minus negative 1 cubed all over 1 minus negative 1. Well, on bottom here we're going to have a 2. And on top we're also going to have a 2 because it's 1 minus negative 1, which is 2 over 2, or just 1. So that's our average slope. This is our average slope. Now we got to find our derivative, which is f prime, and set it equal to that. F prime of x is 3x squared. So when does 3x squared equal 1? Well, that's a little bit of algebra. 3x squared equals 1. Divide both sides by 3. X squared equals 1/3. That means that x is going to be the square root of 1/3. But the question is, we can eliminate d, e, and a, but is it plus or minus or just plus? Well, it's actually both, because you do have to consider the plus or minus, and both of those fit within our interval between negative 1 and 1. So that means that plus and minus would work. B is a place where it does work, but there's a key word in here that means that C is more of a correct answer. All values. Because it says all, you need both. All right. So now I'm really going to stop the video because this is connected to the second one. And then we'll upload all 3 this afternoon as well. Thank you. Have a good day and good luck studying.